open and perfect. Thank you, Rohan. Great. So I have my chat open. And also, I would say that if you want to use audio or video, that'd probably be okay since this is a smaller group. So if you have a question, you can certainly put it in the chat window. That's just fine. But if you wanted to try to use audio, I think that's fine too, because it's not a huge group. You know, I think in class we worry a little bit because it's like, 60 or 70 people. But here I think that'd be okay. If it gets too crazy, we'll just go back to chat. But yeah, so the main thing I want to do here is answer any questions you guys have. And I'm just on my laptop today, and I can do some screen shares and we can write some code and play with some stuff. But yeah, let's go ahead and get started. So if there's any questions or things you want to start with, please either throw those in the chat window or hop on the audio. And I'll go ahead and get things kind of going on my side. Okay, cool. So I see a question from Nick. He says, the only question I had was about the magic commands in Jupyter. Can you briefly explain more about these? Yep, I'd love to. Yep, no problem. So let's do that. It's a great question, Nick. So let me do a screen share. Okay, so I'm gonna do desktop one share. Okay, cool. All right, let me know if my screen share is coming through okay. And where's my chat window? So I got my screen. I'm trying the Zoom app today instead of the Zoom web app. Let's see. Here we go, chat, that's what I wanted, cool. Okay, great, coming through good, great, thanks Austin. All right, cool. All right, let me clean up my screen here just a little bit so you guys can really see what's going on. Okay, great. I think I can close that, right? Yep, I can, cool, okay, perfect. So I got this, I got this. All right, now, so the question was from Nick about the magic functions. Yeah, so let's do that. So I'm just gonna start from scratch here. So I'm gonna open up a new terminal. And I guess I can actually close Chrome for a second. Yep, cool. All right, so you should be able to see my whole desktop and hopefully you can hear me okay. Okay, so I've cloned the repository. Hopefully if you have any questions about GitHub though, please ask there. And the other thing about this review session is, there's no dumb questions, right? So I know a lot of folks are new to Python, maybe new to GitHub. So, if any questions you have, there's really no dumb questions at all. So feel free to ask whatever. So let me go to this repository, which is the original problem. I'll make this a little bit bigger in case it's hard to see. And I'm going to launch a Jupyter notebook, just like we've been using in class. Okay, cool. And let's get into these magic functions like Nick asked about. Okay, cool. So I'm just going to open a new notebook. Let me get this off to the side a little bit. So I'll do new Python 3. Cool. All right. And I'll make this bigger. Okay. So hopefully that's coming through okay. So yeah, magic functions. I use these sometimes. Maybe I can show you two magic functions today, just briefly. I'll talk about this for 5 minutes or so, and feel free to hop in with more questions. So let's do, and I see a question from Austin. I'll hop on that in 1 second. Let me do this magic stuff, and then I'll come back to what Austin's chatting about. So yeah, let's talk about magic functions just for a few minutes here, and then we'll hop to the next question. Okay, so I'm just going to share two with you. So the one that I use all the time is PyLab inline. I use that all the time. Another one that I like, I think this is a magic function, I believe, is timeit. Timeit is pretty cool. So I'll talk about those two magic functions. So there's a whole lot out there. So here we are in Python, right? We're in a Python session. And there's certain libraries we're going to use in this class a lot. The most popular one is called NumPy. And in class we use things like np.array, for example, if we want to instantiate like an array of numbers, for example. It's like an array of the numbers 1, 2, 3. The problem is if I press Shift Enter, right, it's going to give me an error because I haven't imported this np thing, right? It hasn't been imported, it doesn't exist. So I need to import that library. And really the way you should, well, I shouldn't say should, but kind of the more traditional way to import a library is like this. So you say something like import numpy as np, and that imports the numpy library. And now I can use numpy. So now numpy works. The other library that I use all the time is matplotlib. So the traditional way to import that, I believe it's from matplotlib, and I use this sub library called pyplot. Let's see, actually it's this, import matplotlib.pyplot as plt. I think that's let's see. Oh, didn't spell it right. There we go. Okay, cool. So this is a plotting library that we use all the time. And I can plot like, let's see, plt.plot, comma, 1, 2, 3. Okay, cool. So that plots just a simple line like that. So this is like maybe, this is how to import these libraries with no magic function. So the reason the magic functions exist is you might not want to type all this all the time. It's a little bit annoying, right? So instead of typing these two things, and I'll prove it to you that it works in a second. I'll say instead, we can do this, %sign pylab inline. And this actually does one more thing, which I'll tell you about it in a second. But the main thing it does is it replaces these two blocks. So just to prove it to you, I'm going to restart my kernel. I'll restart my kernel. I'm going to comment these out. I'll get rid of these. So they're gone. And I'll show you again that, hey, if I run this or I run this, you know, the library has not been imported since I restarted my kernel, so I don't have these libraries. And now if I do this instead, right, now I can run both of these no problem. And there's one last thing I'll show you really fast. This also does one more thing. So it imports these libraries as NP and as PLT, but it also imports them into the global namespace, which means that if I want to take a shortcut, I can actually just type plot 1, 2, 3. And I don't have to actually use, oh, did I lie? No, I didn't. There we go. I don't have to use the PLT or the NumPy, the NP. So you have the option. You can also, instead of saying np.array, you could just say array of 1, 2, 3. I'll tend to try to write the NP and the PLT just to make it clear what I'm doing. But I would say just know that, when you run pylab inline, it imports both NP and PLT, but it also imports all their functions into the global namespace. So if you want to, it's just faster. But sometimes you don't want to import, you know, you might have another function called plot, and you may not want to overwrite it by importing all this stuff. So you can always go back to this, but this magic function just imports those two libraries for us. So that's thing one. And there's one more magic function I wanted to show you just real quick. And please hop in the chat with any questions. Hopefully that makes sense. The other magic function I wanted to show you was this great magic function called time it. So let me show you the deal. Let's say that we have some slow function or some function that we're interested in the speed of. And this will happen on the programming challenge because your code will time out if it's too slow. So you do have to pay attention to speed. That's a big theme in computer vision. It's one thing to solve a problem, but to solve it with an algorithm that's fast enough can also be a challenge. So, and actually, I realize my video is still on. Hopefully my audio is coming through okay. Let me know if we have any issues, and I'll turn off my, I might go ahead and do it just preemptively. Let's see if I can get to it through the app here. I'm not used to using the Zoom app. All right, I'll leave it for now. If there's a problem, let me know. Audio has been fine. Okay, cool. All right, we'll keep rolling then. So let me show you this time it thing. So let's say you have a function that's kind of slow. Let's say we have some function, my slow function, right? And let's say it's some function you've written and it's kind of slow and you want to know how long it takes. Let's artificially create a slow function. I'll do that by doing like a matrix multiply, for example. So let's do np dot. What would be really slow? Let's do like a big array. So like, let's do a random. So you can do np.random.randin, and it will make a matrix full of random numbers. And I'm going to make this, like, let's make it big to make it slow. Let's make this 100,000 by 100,000, for example. So let's see here. What is, oh yeah, okay. So I need to do this. Cool, okay. So this is gonna make some big array. Just making it is pretty slow. Oh, look at that, it's still running. I might wanna make it a little bit smaller. Yeah, that's really big. Let me interrupt. Okay, yeah, if anything hangs like this, you can restart your kernel, and then you can start over. So let me run this real quick, and I just wanna show you this time it function. Let me change this to here. Let's say we make let's say we have a matrix called A that's going to be 1,000 by 1,000. And we have a matrix called B that's going to be also 1,000 by 1,000. And let's say that our function multiplies these two together. I'm just making a function that's going to be slow so I can show you this time it. Okay, so we have this slow function and I can run it. And I guess maybe I should return the result or something. Okay. Result equals my slow function. Okay, now let's say I wanted to time it. I can do this. So I can use this time it magic function, my slow function. Cool, and I can run this, and it will actually run the function a bunch of times. And actually, that's pretty fast. So it tells me that the function takes 21 nanoseconds on average, and it ran it for 7 times. And it did a a little bit of statistics. Let me just do one little thing. So if I increase this to like 10,000, this should be a lot slower. Let's prove it to ourselves. Let's see. So this is how long it takes to multiply two 10,000 by 10,000 matrices. So while that's running, it should come back with a slower number. We'll go ahead and think about the next question. But those are just two magic functions that you can use. The PyLab one is pretty probably the most common one that you'll see, and there are other ones. Okay, great. Hey, that's weird. That should be slower. So it shouldn't take 21 nanoseconds. Have we found a little bug or something? Oh, I think I know what's wrong. Do I need to do this? Let me go back to the smaller size. 21 nanoseconds did seem really fast. Let me try something. I think this is going to give us a different number. I think it wasn't actually calling the function because it didn't have the, yeah, there we go, it's slower, 70 milliseconds. Okay, cool. So make sure if you're timing a function, you include the parentheses, because I think if I just type my slow function, it won't actually call the function. It will just print it or something. Yeah, it just tells me where that function is located. Okay. All right, cool. So Austin says, everything yesterday was quite the task. Got through it though, great. The hardest part was not realizing I needed to clone the repository into Conda. Yeah, there's some like kind of, you know, initial learning curve with that. Please feel free to post on Piazza. We kind of debated how much of that we wanted to include in the class. But yeah, whatever you run into, hopefully we can address it in Piazza. So Austin says, are magic functions for Python or only in notebooks? Yeah, it's a great question, Austin. So let me show you something. So let me go back to my terminal real quick. So here I'm in my terminal. I'm gonna make it a little bit bigger. So it's another terminal. So I can launch Python. So if you have Python installed on your computer, if you type Python in the terminal, you'll have launched a Python environment, and you can do things like add 1 + 1, things like that. What Python does not have are these magic functions. So if I do pylab inline in the terminal, I get an error, right? So the thing I want to show you then, and I'll get to this next question in 1 second, good question. So there's another version of Python called IPython, and the I stands for interactive, and it has some more features. And I believe now I can run pylab inline. Well, I guess I can actually, that's interesting. No event. I think I should be able to use these in here. I'm surprised that I can't, because my answer to your question was going to be that mostly magic functions are for the notebook, but we should be able to use them in any IPython session. I'm surprised that didn't work. Let me try one more thing really fast just to see. Time it, actually I have to import time. So yeah, I would say they're mostly for the notebook, but you should be able to use them in any IPython session. Yeah, like this one I think is gonna work. I'm not sure why that pylab one was giving us trouble. Yeah, the time at magic function worked. Let me try this one more time. Oh, you know what it is? Inline, that's a special thing. Oh, this does actually one more thing, guys. I forgot to tell you this. So the inline does actually one more little thing. The reason it's called inline, I totally missed this. I apologize. I'm just so used to using this. So inline makes your plots in line with the notebook. Let me show you what I mean by that. So there's another option here. I think it's called pylab. I think it's Qt. Let's try it. Oh yeah, do you see that? So when I change to pylab Qt, now my figures pop out into this nice little window, which might be nice if you can like zoom in on it and stuff, which is kind of nice. So this could be useful sometimes. So that's pylab Qt mode. What inline mode is it puts your figures in the notebook like this, right? And there's a few other options too. I think there's a pylab interactive or something like that. You can Google around for it. I forgot what it's called exactly, but the reason pylab inline didn't work in just a regular IPython session was because inline is just for the Jupyter notebook, and that makes the plots appear in the notebook itself instead of popping them out into your operating system, basically. Okay, great. Hopefully that makes sense. So Robert is asking, how do you open a notebook? Is something you need to download or is it web-based? Yeah, great question, Robert. And Robert, this will matter a little bit, and I think this is something the TAs can help you with. If you don't mind throwing in the chat, are you on, what operating system are you on? Are you on Linux, Windows? You're on Windows, got it, okay, cool. So the installation process, we have some instructions in the README. So let me start there for you. So, everything in this class starts at github.com/UNCCV. Well, almost everything. And if you go to like the original problem, for example, I think we have a little bit of instructions. We should, yeah. So we recommend the Anaconda distribution of Python. So to open notebooks, you do need to download Python and this package called Jupyter. And the best way to do that, we find, is to really use the Anaconda distribution. So I clicked on this link from the README, and this takes me to the Anaconda page. So Python is an open source programming language, and there's different distributions of it. The Anaconda one is nice because it comes with what's called a package manager, which lets you install packages really easily. So what we do then is, so you go to this website, you go to download, and then what you'll do is you'll select your operating system. For me, I'm on Mac, so I would install this one. And it has a nice graphical installer. Robert, you would select this one. After you download it, now here's where it's going to get a little hairy. So I am not a Windows expert. This is where the TAs are going to be able to help you a little bit more than me. Rohan, I forgot, are you on, what operating system is your daily driver right now?
Windows, Professor.
Windows, yeah. So Rohan is your man. Yep. So and maybe we can just talk about it, Rohan. So to answer your question, Robert, to run a notebook. So after I've downloaded and installed this installer on Mac, what I do is I open up a terminal, and then I navigate to wherever I want to be. And to launch the Jupyter notebook, I just type Jupyter notebook. That's pretty similar on Windows, right, Rohan?
Yes, Professor. Or also they have one option where they can just launch the notebook and then go ahead navigate their way to the folder they want to, and then they can launch a new notebook over there. So they'll
Okay.
have a new notebook launched in the folder they want.
Right. Okay, that makes sense. Perfect. So Robert, what I'd recommend you do, maybe you can do it right now if you want, is go ahead and download Anaconda onto your Windows machine. And give that a shot, right? And just hop back in the chat if you have any more questions as you go. And I'll try to address them if I can. If I can't, then Rohan can definitely help you as well. So I would start there. Cool, and Austin says that My Way works in the Jupyter Notebook. Cool, okay, great. And there's other things you can do in Windows, and Windows can be a little different. The paths are different sometimes. But our TAs have more experience with Windows than me, so they can help there as well. Cool. Okay, great. And yeah, so Austin makes a good point. Make sure that you cloned the repository. Let's talk about cloning just for 1 second. So this is a GitHub repository. GitHub, if you haven't used it before, is a very popular version control set of software built around the technology called Git. Git is version control software, and GitHub is a website and a web app that allows you to collaborate on Git projects. Excuse me. Does anyone know who invented Git? Who wrote Git? Just out of curiosity, this program called Git, G-I-T. Just some fun trivia. So the inventor of Git is Linus Torvalds, who also wrote Linux. So two of the most popular programming things today were written by one person, which is pretty crazy, or at least they were begun by one person. Okay, so here we are on GitHub, but the thing is, how do you get the code, right? So I believe you can actually download the code as a zip file, like that would be okay. My preference for you is to clone it on your using a command line. And you can download the zip, that will work fine. But to clone the repo, I think we have do we have some instructions on cloning here? Let's see. No, we really don't. We're assuming that you cloned first, basically, I think. Yeah, we're assuming that you've already cloned. Okay. So to do that, it's pretty straightforward. So what you do is you go up here to getting code, and you copy the URL to the code here. And there's a few ways you can set this up, but HTTPS should work just fine. You go back to your browser, or to your terminal, excuse me, here I am in my terminal. And I think I already have a copy of the original problem. Yeah, I'm gonna remove it, so just so I can clone it again. I'm gonna do rm, the original problem. Oops, I have to do sudo rm-rf, the original problem. This will remove that repository, or that directory. You can also do this with your just operating system GUI. Okay, cool. All right, so it should be gone. So now I type git clone, and then I paste. I'm going to paste in that URL that I just got. So this is https github.com unccv, the original problem. And if I press enter, then it will clone and it'll make a copy of all that code to my computer. Okay, cool. So let's see here. So Chandan, hopefully I'm saying your name correct, right? So you said, how can we create a new environment in the Anaconda terminal and change the environment? That's a great question. Good question. Let's talk about that. And just in general, there's a really nice Anaconda cheat sheet, and Austin is answering the question right there. So thank you, Austin. I will echo your answer. It looks like you got it right. But just real quick, just to kind of help out everyone, there's a really good Anaconda cheat sheet. I have a printed copy of this in my office that I use all the time. Although I don't know where it is right now, I got to go find it. But the Anaconda cheat sheet is really nice. So let's see if we can find the answer to Chandan's question. So he said, how can we create a new environment and then change the environment? Yep, that's a great question. So using environments. So this is how you can create a new environment, Conda create. So you give your environment a name. This is the name that they chose for this environment, and then you tell it which version of Python. We're mostly going to be using, I believe, Python 3.6, but 3.5 is fine as well, or just 3. Oh yeah, I think we're just recommending 3. That's fine. That should use the newest version of 3. So the way you create the environment is here. You type this in, and let's just do it just to show you how it looks. And then the way you activate the environment is you type conda activate, which they really should have here somewhere. Do they not have it in the cheat sheet? That'd be a bummer. Let's see, activate. Oh yeah, there we go. Yeah, this is how you activate an environment. Oh yeah, and this is interesting. So they give you a nice breakdown here. I'm glad I looked at this. So was it actually right? Did I just totally miss it? Was it actually right below what I was looking at? That's embarrassing. So on Windows, it's apparently just activate in the name of your environment. And on Linux and Mac OS, it's source activate. And I believe you can also type conda activate. But let me just show you real quick. So let's try it. Let's say we want to create a new virtual environment. Let me make this a little bit bigger. So I'm going to do conda create. The name I'm going to give my virtual environment is, let's call it test environment. And I want to use, let's say, Python equals 3. So instead of Python 2. So this should go create a new environment. I'm going to say, yes, please install all those packages for me. And then in a second, we'll activate it. And I'll just show you one or two more little things. So here we go. And here it's actually telling me how to activate it. So I can do conda activate test environment. So I'll type conda activate test environment. And now you can see that I have this little parentheses here with the name of the environment. So it's been activated. And now, actually, just let me show you two more things real quick. So I just made a new environment, and it's actually not going to have a lot of the libraries that we need. So let me show you something. Actually, what's a good way to show you this? So if I launched a Jupyter notebook from here and tried to import NumPy, it actually wouldn't be there. Let me show you. So let's just show you real quick. Actually, I can't even launch a Jupyter notebook, I bet. Watch. Yeah, so there is no, Jupyter has not been installed because I just made a new virtual environment and I haven't installed Jupyter. So the way we have you do this in the original problem is we have you run something called, where is it? Here we go. Pip install -r requirements. So requirements, this has a list of all the packages that we use in this module. Let me show it to you real quick. So requirements is right here. So we use matplotlib, ezdict, pillow, and I don't see Jupyter here, which is kind of funny. How are we getting Jupyter set up? Do we not have it in our requirements? That's kind of embarrassing. Let's see. Do we have another way that you get Jupyter? Oh, I have you install it here. Okay, I'm having you install Jupyter separately. Okay, sure. All right, great. So what you do then is if you're missing a package, and I'll just show you one more little thing, and this is on the cheat sheet. If you do conda list, this will give you the names of all the packages that you currently have installed in this environment. And notice that there's no Jupyter, so we need to install Jupyter, conda install Jupyter. And for many of the packages, you can install them either with conda or you can use a package installer called pip, P-I-P. You'll see us use both in this class, and they're mostly interchangeable. Mostly they do the same thing, but there's a couple little differences. So I've installed Jupyter, so now I should be able to launch a new Jupyter notebook. Oh, maybe not. Let's see. Oh, do I have to exit and come back? Let's see. This is why live coding is good, because I'll run into these little funny things. Did it not actually install it? That'd be funny. It threw an error. I missed it. I was talking. Let me try to run it again. What error did it throw? Let's see. Did I type it wrong? Oh, I spelled it wrong. Thank you, Vanessa. Yep. I tried to install Jupyter. So it's Jupyter, like that. Yep. Cool. Thank you. Great. All right, and I see a new question. I'll get to that in 1 second here. I just want to show you 2 more things real quick. So there we go. So now I'm installing Jupyter. So now this should all work. That'll just take 1 second. And then Austin asks, while this is going, I'll answer Austin's question real quick. So he says, for each project in the class, do you recommend creating a new environment? Probably. It's not a bad idea to kind of keep things separate, because what you'll end up with, and kind of like I hopefully warned you a little bit at the beginning of class, this can get really frustrating. Like you'll run into some problems, and it'll just take some time to debug. But if you do keep things nice and separate, and you want to go back to a previous environment, it's kind of nice because it keeps everything separate, because it is kind of easy to break your environments. You'll see that happen from time to time. So yeah, using virtual environments is a nice idea, and I probably would recommend creating one for each module. I think that's probably a good idea. So now I finally could launch the Jupyter Notebook from my new virtual environment. And let me just show you one last thing. So if I try to do PyLab inline, I think this might fail unless Jupyter has actually installed this stuff. Yeah, this fails. And the reason it fails is because I have it installed matplotlib. So the way I fix that is I'm going to close out of my Jupyter Notebook here. I'm going to leave. I'm going to go back to this. I'm going to end the session. And to end a session, you just hit Control-C to end a session. And now I'm going to pip install matplotlib. I could also do conda install matplotlib. Those should both do basically the same thing, like I said. I'm going to pip install here. Either one should work just fine. And then when I went back into the notebook, it should be able to import PyLab inline, no problem. I'll prove it to you real quick because this is a review session and I want to make sure that what I'm showing you works and that I didn't miss anything. So Jupyter Notebook, let's have a look here. Okay, so we're back in a Jupyter Notebook and here is a new Jupyter Notebook. And if I do PyLab inline, let's see, can we import the stuff we want? Yes, so there you go. So that's most of setting up an environment. Okay, cool. All right, what other questions can I answer, guys? What else is on your mind? Where do you recommend we actually work on our code within the notebook? Oh, I see what you're saying. Yep, that's a great question, Austin. So yeah, I usually work in the notebook first. And then let's say after my code gets a little bit more mature, I might switch to a script. So let me show you what I mean. So for development purposes, I do like to work in the notebook because I can just run experiments really, really fast. But let's say I end up writing a method that I want to use later. There I might shift towards putting that inside of a script. And let me just show you one thing really fast. So let me go to this repo, the original problem. So if you go to challenge, which you should be getting here soon, for your submission, you will actually be working with you won't submit a Jupyter Notebook, you're going to submit a .py file. So here's an example .py file. I've opened this .py file in my favorite text editor. It's called Sublime Text. It's a little bit old now. I'm kind of old. I don't know. There's some cooler ones now. A lot of people like PyCharm. A lot of folks like JetBrains. No, JetBrains makes PyCharm. VS Code is another popular one. But either way, whatever tool you want to use to open .py files is fine. You can even use a text editor. But after you kind of figure out what code works, you'll kind of put your code here, right? So usually after working in the notebook for a while, you'll kind of know what your code is. And in this case, for this programming challenge, for example, you'll actually submit to us a .py file, just a script basically, instead of a Jupyter notebook. Hopefully that makes sense. Okay, what other questions can I answer? Do we need to use Jupyter themes? Can you see a small demo? Yeah, absolutely, yeah. So this is in the README here. I personally use Jupyter themes less than I used to, but let me just show you. They're pretty cool. So you may want to change how your Jupyter notebook looks, right? So let me show you how this kind of works. So first of all, there's this package called Jupyter themes. And if you don't have it, you can just do pip install Jupyter themes like that. And it should install this package. And I think I already had it installed. Cool. So to change a Jupyter theme, what you can do is you can type a JT. And what you can do, for example, like let's say that I want to use a different theme. So I think I can see the themes by typing list. Yeah. So if I do JT --list, this gives me a list of different themes. And these are just ways to, it'll just change the appearance of your notebook. I will say at work, I work in notebooks a lot, and I usually like to use a dark theme. And I think a good dark theme, I think Ocean 16 is a nice one. So if I go to JT, and actually, let me just show you one more thing. You can do JT-help, and it will kind of give you some instructions about the different arguments you can pass in and things like that. And I see that if I pass in -T and the name of a theme, then I can change my Jupyter theme basically. So I'm gonna do one of the themes I see is Ocean 16, which I think is a theme that I like, I think. So if I do JT-T Ocean 16, it should change my theme. And let's cross our fingers here. If I refresh, yeah, there you go, right? So see, now I'm in this dark mode, right? So it can be nice. You know, it's just a style thing. You know, the code you're gonna write is the same, right? But it can be nice to have like a dark mode or like have your appearance change a little bit from the default Jupyter. So by no means is this required, but it's just a nice thing to know. Nice to have some more options. So I'm gonna type JT-R to reset my Jupyter theme. And now I'm gonna refresh my page and I should be back to the plain old boring white. Yep, cool, okay. Hopefully that answers your question. Cool, any other questions? What else can I answer? If you've started the programming challenge, you may have some questions about, you know, how to start, things like that. If you do, we can definitely talk through those. Really, no questions are off limits. We should have called this an AMA. So yeah, whatever you want to ask, this is your time to ask any kind of question.
Professor, I would like to add one thing.
Hey, Arvind. Yeah, how are you?
Yeah, I'm good, Professor.
Good, good.
I just wanted to mention that after working on Jupyter Notebooks, we can actually download it as a .py file.
Oh yeah, that's right. And Arvind, how do you normally do that? Do you normally do like a download as like this?
Yes.
Yeah, perfect. Yep. So that's a great point, Arvind. You don't have to copy and paste. You can actually download it. Now, it will bring some extra stuff down. I think that you might have to. Actually, I very rarely use this. Let's see. Let's see here. For me, it just downloaded it as a an HTML document. But let's see. I bet if I go to downloads, then it will be. That's not a function I use very often, but that is a cool option to have. Okay. Why did it? That's weird that it downloaded as an HTML. Might take a little bit of experimentation. If you have questions, Arvin should be able to answer. Maybe I clicked the wrong thing. Oh, there we go. That's what it is. I clicked the wrong thing. That's what I did. Okay. No, it's still HTML. It's so weird. Okay, I'm not sure. But does that work better for you, Arvin? Does it actually download a .py file instead of a, for some reason I'm getting HTML files.
Yeah, it downloads as a .py file for me.
Okay, interesting. Okay, so if you want to try that, feel free, and Arvin can help you debug. He might have to help me debug later because I'm not sure why it's not working for me right now. Cool. All right, so I see Robert is saying, I've installed Anaconda. Where do I input the code to install Jupyter? Okay, cool. And you're on Windows, right, Robert? Yeah, so I think Robert, so on Windows, right, guys, he has to open up a, what's it called on Windows, a command prompt? Is that what he has to open?
Yes, Professor. He can do it through command prompt, or if he has installed Anaconda, if he has installed Anaconda, then he can get the front end. He can open up the app and he can install directly from there.
Okay, cool. Yeah, so
From the
okay,
Anaconda app.
cool. So yeah, you've got two options, it sounds like, Robert. There's an Anaconda app, or you can use command prompt, which is kind of the Windows equivalent of terminal on Mac or Linux. Cool. Austin asked, we have limitations on packages for the, oh, you do, yeah, Austin, great question. So yeah, on the first module, you can't use anything outside of the packages that we have, and we kind of have you install to set things up. So for example, you cannot use a package called OpenCV. OpenCV has implementations of a bunch of the edge detectors that we're using. That would kind of be cheating. So yeah, and I think, I think in the challenge, I mentioned which modules that you're allowed to use, I think I have a list, let's see. And maybe, do you guys know where that is offhand? I think we have a list somewhere of exactly which, it might be in the notebook. It might be here. Here we go. Oh, it's in sample student. Okay, cool. Let's see. Oh yeah, here we go. So you're only imported, thank you so much. You're only imported to, permitted to import NumPy and methods from the util module. Yep, there we go. Okay, yep, that's it. That's all you get. So you'll get to use more and more libraries as we go on, ending ultimately with PyTorch and FastAI will be the most sophisticated libraries you get to use. But yeah, right now I'm intentionally not giving you a lot of options. Good question. Okay, Robert says opening the app doesn't do anything. Okay, interesting. All right, so yeah, Robert, I'm not sure exactly what the problem is. It might be helpful to post some screenshots on Piazza. That could probably help get it moving forward. I would recommend doing that, I think. If there's if you have more questions as you go, feel free to keep asking them here, but I would try to maybe put a screenshot and a description of your problem on Piazza, because I know a number of folks have more experience with Windows than me, so they can probably help too. But yeah, Robert, I would recommend put a screenshot of what you're seeing on Piazza. Okay, what else can I answer, guys? For our programming assignment, once we have the edge and how to identify it's a brick, okay, oh, I see what you're saying. I know we can identify them with human eye, but how do I do it with my program? Yeah, that's a great question, Ravina. Yeah, fantastic. So yeah, that's really, you've kind of hit on like kind of the essence of computer vision, right? So you can do it as a human, right, of course, but how do you make a computer do it, right? It's a really, really good question. So I think if I answered your question, then I would give away the answer to the programming challenge, and there is no one answer, but I'm happy to kind of poke at it with you. But you're gonna have to go a little bit further. So I'm really intentionally, not giving you all the answers. And let me go ahead and save this, save as um, review session 1, cool. But let's just talk about a couple ideas, Ravina, real quick. And maybe we could walk through some of this if we want. We can ask the class if they want to walk through kind of some of the process you just talked about. New notebook, cool. Maybe some direction. Yeah, sure. Let's do it. Let's do it, Ravina. Yeah. So, so we've got 20 folks on, and we've seen some questions, or 26 folks, something like that. 27. Okay, cool. So yeah, let's kind of just walk through the programming challenge a little bit. And like I said, I definitely, on purpose, I'm not going to give you a full answer because the point here is for you to think creatively. But let's talk about some ideas basically. Let's do like maybe some ideas on the programming challenge. Okay. Oh, and one more little thing. I keep switching back and forth between markdown cells and code cells. You can do markdown in the Jupyter Notebook, so you can have text basically. And these two hashtags make it like a title font basically. If I do 3 hashtags, it's a smaller title font. Cool. Okay, and I'll keep walking through this to kind of get at Ravina's question a little bit, but I'll look at other questions as they come in here. So I'll see if I can get your name right. Let's see. Bahardwaj. Let me. All right, let me know if that's right. You can hop on audio if you'd like. All right, yeah, okay, all right, I'll take it. I'm sure it's not perfect, but okay. When I use the pill module of images, the methodology for converting a standard image to grayscale is determined by the formula. Oh, that's interesting. How is this different from the mean? Okay, where did that formula come from? Is that in the pill documentation or something? Where did you get that formula from? From the pill documentation. Interesting. Perhaps the pill library supports different intensities of red, green, and blue or something. That's interesting. I'm curious about that. I'd like to learn a little bit more. I haven't seen that exact formula before. That's kind of funny. They're doing a different weighting, right? So they're saying that we're going to weight the green channel more. So maybe it's something about how they're storing there must be some assumption in that basically. If you don't mind, chat a link to that documentation. I'd recommend just using np.mean for now. But what that's doing is it's weighting the green more than the blue and the red. And there must be some assumption about how the relative intensities of those 3 color channels for some reason. What we're doing with np.mean is we're just weighting them all the same. We're saying we're going to take an average and equally weight red, green, and blue. There must be some reason they're using those numbers. I'm not sure what it might be, the color space they're in or something. That won't really come up in this class, but I'm just curious. So yeah, if you don't mind, just chat, or you can email a link to that documentation, because I just want to know. But I wouldn't worry about that. That shouldn't impact us in this class too much. Just using np.mean should be just fine. But yeah, good question. So yeah, let's do some ideas on the programming challenge. Let's go ahead and start thinking about getting some data real quick. So I think I'm in the right location. Great, thank you for that. I'm just going to make a copy of that real quick. I'll put it up here for now, and then I'm going to put it in my list to look at a little bit later. That's very interesting. Oh yeah, interesting. Image.convert. Is it because of the color space? Okay, this is a little bit off topic just because we won't cover this in this class, but I think it's, oh yeah, this is the special Luma transform. Yeah, so this is using this ITU-R601-2 Luma transform. This is assuming something about how the color space is saved, basically. Yeah, exactly. Okay, so yeah, don't sweat this too much right now. This is using a special color space that we are not too worried about in this class. Good question. Okay, so yeah, some ideas on the programming challenge. So let me do a little bit of coding, Ravina, and then we'll kind of talk about some ideas. And let me kind of write down your question here. So using code in class, we know how to get to edge images, and maybe we'll walk through that in a second if everyone's interested. But how do we figure out if it's a brick, ball, or cylinder from those edge images? Okay, so there's lots of different things you can do, right? There's many different ways to solve this programming challenge, but let me start to get you thinking a little bit, Ravina. So here's one idea that I kind of like. And it involves a little bit of thinking, but let me just throw one idea. This won't fully solve the programming challenge, but it's one idea that I kind of like. And I guess really I'm going to need some code to show you this. So let me go ahead and import an image or two real quick. Let me go ahead and do that. So I think here, let me go back to this page. Okay, so let's see here. So my data, I believe, is stored. Let me see if I can get an image real quick. And this can just be kind of a walkthrough importing data into Jupyter and all that good stuff. So let me do this real quick. So I'm gonna import this thing called glob again, which is a way to get to kind of list the contents of a directory. So let me do glob.glob of /data. I think this is where my data is, and this, yeah. So this star operator, this is like the wildcard. So this will show me everything in this data directory. This is where I downloaded the data for the challenge, and there's easy, medium, hard, and medium 2. Let me just look at easy for a second. So what's in easy? So we've got brick, ball, and cylinder images. I might actually go ahead and do this. So if I do wildcard / wildcard, I should get, yeah, there's a nice list of all my paths to my images. And I can even do this if I want, and that will just return JPEGs, for example. Okay, so these are my paths. So IM paths. Cool. All right. And let's load up an image. Let's start with the first one. Let's say I = 0. And let's do IM paths of I. So that will load up the first image. Let me do IM read to load that. And I'll say IM equals. So I'm going to load up that first image. Oh yeah, and I haven't imported. Yeah, so what I'm going to do is this pylab inline. So part of matplotlib includes IM read, which lets us read images. So I'll do IM show, IM, cool. So there's an image of a brick. Okay, so let's grab a couple functions, which is probably what you guys have started thinking about, I'm guessing. So let's go to, actually what I might go to is I think I have a little utils folder. So if I go to where I downloaded the repository, if I go to util, and if I go to, let's look at filters, for example, we've got Roberts Cross, filter 2D, make Gaussian kernel. Okay, cool. Yes, great question, Austin. Yep, so you are permitted to use any of my code. Exactly right. It's like the one person you're allowed to copy from is me. So yes, you are welcome to use exactly this code. Good question. Okay, so we've got converting to grayscale. That's cool. I kind of want to hop in my Sobel notebook, I guess, real quick. So I'm going to use this filter 2D method. I could import it, but for now I'm just going to copy and paste it. So I'm going to grab this filter 2D method. So I have that in my notebook that I can use. And I think I'm going to, let me go to the Sobel notebook real quick. So this was our last lecture, was on the Sobel edge detector. And let me just go ahead and grab an example that I want to kind of use to get us going. So here's the Sobel kernels. That's cool. Okay. And let me go back here real quick. And maybe I'll go ahead and grab that convert to grayscale method, because yeah, what I really want to do is just kind of do the same thing we did here. And that will get us talking about some ideas of what to do next. So let me go back to the Sobel notebook. So I copied that. What else do I want to steal? I'm going to steal this from the Sobel notebook. This lets us compute the X and the Y images, X and the Y edge images. And what else do I want to steal? I want to steal the magnitude for sure. You could put this all in one nice function. That could be helpful. And then what else do I want to grab from my lecture? Let's see. I think I want to get the angle stuff, right? So let me grab this. Yeah, G direction. Cool. Okay. And I think I have almost everything I need to kind of get us thinking here. Yeah, I think that's fine. The other thing I want to grab real quick is my convert to grayscale method, which I could really do in one line of code, which I might just make a streamlined version of this real quick. I'm going to do that. So, oops. Okay. I'm going to make just a little streamlined version that takes up less space. I'm going to do just all in one line. There we go. Cool. So we've got convert to grayscale. We've got filter 2D. We've got our Sobel kernels. We're going to take our image. We're going to convert it to grayscale. We're going to compute the X and the Y edge image. We're going to compute our overall edge image, and we're going to compute our direction. Okay, cool. All right, so now we can really get into Ravina's question. So first, let me make sure this makes sense. Yep, so there's our edge image. That seems pretty reasonable. And then G direction, for example. Let's IM show G direction. Okay. Cool. All right. So remember, that was kind of noisy from last time. Okay. So let's push a little bit further. Let me just give you one idea to start thinking about. So yeah, and let's go actually 2 steps further. Let me go back to the Sobel notebook, because what I really kind of want is I want this, but I want the edge version. Let's see. Okay. Yeah. All right. Cool. Is that what? Ooh, I actually know what I want. Yeah, let's go back here for a second. Okay. So yeah, let me just give you one quick idea. So an idea here is let's see if we can use something about the direction of the edges to kind of help us. Just an idea. And there's many ways you can solve this, like I said. And in the next lecture, we'll get into the Huff transform, which is also could be helpful with this programming challenge. I think it will be. But just to give you one idea about how you might go from edges to figuring out if something is a brick or a ball, for example. So let's explore an idea about the direction of the edges. So I have a theory, which is that if we look at the distribution of the direction of our edges, then we'll see different kinds of distributions between our balls and our bricks. Let me get into that in a little bit more detail here. So what I want to do is I want to grab the direction just at the edges, like we did in class. So let's cover how to do that. So first, let's threshold our edge image. So let's threshold it like this, kind of like we did in class. So yeah, and maybe I'm going to tune this up just a little bit, maybe a little bit higher. So I'm playing with this threshold. That's kind of better. Maybe we can go even higher. Okay. So yeah, there's some of the edges of our brick. The bottom edge is not great, but what I want to kind of do is try to pull out the direction of the edges. So let me do this. Okay, cool. That's maybe a little bit better. And now what I want to do is I'm going to take G direction, and I think what I can do is I can sample it like this. Let me write this line for you real quick. Okay. So what is this going to do? So G direction of G greater than 0.75. Can anyone tell me in the chat, what am I doing with this line of code here? So what I'm doing is I'm sampling, remember that G greater than 0.75, right? What this is doing, G greater than 0.75, this is making a Boolean image. It's this image, it's all trues and falses, right? And remember, G direction is this thing, right? It's this really noisy thing, right? By taking G direction of this Boolean, I'm just pulling out the pixels in this G direction image that have a high edge value. So I'm just kind of sampling those edge pixels from the direction image, the image that has the direction of the gradient or of the edge, basically. When I do that, I get basically a long list. So let me give this a name. So let me say this is going to be the direction of edges, for example. Okay. And let me just look at the length of it, for example, real quick. Oops, let's do this. Okay, and let me ask you guys. So 1303, that is the number of pixels in this image, basically, right? Okay, Robert, you just posted on Piazza. Great. So yeah, either one of the TAs or another student will have a look at the issue you're having launching the Jupyter Notebook. Awesome. Cool. Thanks for doing that. Good deal. So there are 1,300 points in this image that have a high pixel intensity value, that have a value greater than 0.75. And what I'm doing is I'm grabbing all of those points with this line of code. I'm grabbing all those points from this edge image. So I'm getting the direction of all the edges. Because here's what I really want to show you. Ready? So I want you to start thinking about start thinking about the data a little bit. So I'm going to use a method called histogram. So plt.hist. And what I'm going to do is I'm going to make a histogram of all these directions. So, and I'm going to use 50 bins in my histogram. You'll see what that means in a second. So cool. Okay, and I'm going to turn on my grid just to make this look a little bit nicer. Okay, and let's put a title. So title, direction of edges of brick. Okay, cool. Okay, so look at this pattern we're seeing. And actually, before I ask you a question, because I'm trying to kind of point you towards one strategy. There's many strategies out there. I just want to show you one and maybe get you thinking a little bit more about how you might use some of the data that you're getting from the Sobel operator. Let me do one more thing for you. So this is the direction of edges of our brick, okay? And I'm going to ask you about why it's shaped like this in a second. That's going to be really important. But I want to do one more thing first, actually. So I want to import another image and do the same exact thing. But this time I want to import a ball image. Let's see. Okay, cool. So I have all these IM paths. Let's find an IM path that will be for a ball. Let's do this. So let's do ball 2 just for fun. So this is going to be ball 2. So IM equals IM read. I'm just going to directly pass in the path. Cool. So this is going to be a ball. Cool. All right. And what I want to do, actually I want to do this. So I want to do this first. So I'm going to import an image of a ball, convert the grayscale image, convert the Sobel transform. And then I'm just going to do the same exact thing. I'm going to compute this direction of edges thing, just like this. And then I'm going to visualize it exactly like I do here. Except now it's going to be for a ball. So direction of edges for a ball. So let's do it. Let's see what we get. Okay, that's interesting. I bet this ball has a little gap in it. Let me show it real quick. Let's see here. IM. Interesting. Let me actually show. And I might want to tune my threshold a little bit, but that's okay. Let me show this. Yeah, there's kind of a little gap in the bottom. But here's what I really want to show you. Okay, so this is the distribution. This is so in our brick, there's a bunch of kind of edges that are pointing this way and a bunch that are pointing this way and a bunch that are pointing this way at different angles. Remember, these are our angles from -pi to pi, which are, it's really a whole circle of angles. And here is our ball. And I might actually do a different ball just to make my point here, but should be a common thing you'll see. That's a little bit better. A lot of these have little gaps. Let me try adjusting my threshold real quick. That's a little bit better. Not that much better though. Let me do one thing. Let's play with this threshold a little bit more. So IM show G is greater than 0.5. I'm just trying to find a good threshold that will get the bottom of the ball. And this is kind of like, if this feels kind of clunky and weird, that's fine, because image processing is kind of clunky and weird. As we get later into the class, you're going to learn more sophisticated techniques, but we're starting with the basics. So if it feels a little bit, like it's kind of brittle and it feels like you've invented some kind of weird process that only works sometimes, that is exactly how it's supposed to feel. All right. So I guess what I want to get at here is this is the distribution of the direction of the edges on the ball, and it's pretty spread out, right? You've got edges pointing in all directions really, except for there's a gap here. But what do you see here, right? Why is the distribution of edges of the brick, so of this image of our brick, why is this shaped like this? Why is it so spiky? Any ideas? If you know why, throw it in the chat. And Austin, you're right. This is the amount of pixels at each radian, basically. It's so what this spike means is that there's 140 pixels that have an angle of about 1.5 radians, which is about pi over 2 or something. It's like 90 degrees. But why are we seeing this, right? Why does the brick have this spiky distribution of edges? And why does the ball have a much smoother distribution of edges? Corners, yeah, corners are part of it, right? So yeah, you're really, I'd say that's part. Sides, yeah, definitely. So you think about it, right? So the brick, right, it's got a bunch of, it's got this long linear straight line, right? So all of these points should have an edge going in the same direction, right? So that results in a big spike, right? And then all of these points have the edge going in a different direction, and that results in another spike. In our circle, you've got edges going in every direction, right? So you're going to get this nice smooth distribution, right? And what I'm really poking at here is, can you use some information like this to make an algorithm to tell apart the brick from the ball? I really encourage you just to try little pieces, try little simple things first. So try your algorithm just on bricks and balls first, for example, right? Forget about cylinders, see how you can do, and then kind of build on it from there. And I'll just show you one more little thing. So the histogram, there's other ways to do histogram, but I think what you can do, values equals plot.hist of the direction of edges. Cool, does that give me what I want? Yes, I think. Right. You might have to look at the documentation, but what I'm really getting at here is that this function can also return the value of each of these spikes to you, and you might be able to use that value. Like, you could just do a threshold. You could say, okay, if any of these bins is greater than 100, because if you look back here, none of these are greater than 100, right? So a very simple brick detector might be, okay, take my brick, compute the edges, make a histogram like this, and get the histogram values. And if any of those histogram spiky values are greater than 60 or 80 or something, then I'm going to say it's a brick. And if none of them are, I'm going to say it's a ball, right? Because here, look at all the spikes. The biggest spike is 30, right? So it's much smaller. So that's a very simple algorithm. I'm not sure what that would score you on the programming challenge. I'm guessing it would score greater than 4. So if you just guess randomly, you get a 4 out of 10. I bet this would do better than random. I bet you would get a 7 or maybe an 8. We'll see. I'm not sure. Maybe it's only a 6. But this is just one idea, right? But this is the kind of things that I expect you to be trying. And there's, like I said at the beginning of class, there's no like one magical thing I'm going to tell you and be like, oh, just do it this way. So this is just one idea, and hopefully this has got you thinking about maybe other ideas or other ideas that you might try. And we're going to be doing the Huff transform soon, and over the weekend you may want to look at the Huff transform a little bit, and you could even try it, just see if it can help you, because that's another technique that could be useful here. But I know I haven't fully answered your question, but that's on purpose. I just wanted to get you thinking a little bit, because really we're grading this challenge very nicely. You don't have to do terribly well as far as performance. You know, if you get 60% of them right, you're going to do well. What we're really looking for here is just for you to experiment and try stuff. And we are putting a little pressure on you, though. This is mostly graduate class, right? So we're going to put some pressure. And it's just, the whole point of that is just to kind of force you to experiment, because this is just going to be different than other programming classes, because you're learning a new science. This is new, and there's no one definite answer I can give you. So being a little creative is really valuable, and I'm trying to force you to be a little creative. So just try to have a good attitude about it. I know it's a little bit different than some other classes, but if you just embrace it as kind of a challenge and something that maybe is a little bit fun and you get to experiment, I think it'll be more fun than trying to stress out or worry about doing it exactly the right way. There is no right way, definitely not. Cool, I'm glad that helped, Ravina. That's awesome. Good luck. Thank you for asking. Cool. Okay, so it's a 4:30. So we're already an hour in. Wow, that hour went fast. So I've got a little bit more time. I think we scheduled till 5, so I can stick around a little bit longer. Are there other questions that I can answer while everyone's here? Let's see, how many folks do we have on our call? We got 26 still. You guys are really sticking around. Okay, cool, great. I'm glad. Hopefully this is helping. So yeah. So what else? And then Arvin and Rohan, if you have anything else to contribute, please do. So let's see here. So Robert has asked a question. He says, can the project proposal be something that already exists? Can you tell us what you're thinking about? That might help us with an exact example. Bye, Ashish. Have fun at work. You're welcome. So it can be something that exists, Robert, but maybe something that we would like you to see you take a new spin on it, basically. So if it's something that exists exactly and you're just doing the same exact thing, then we probably are not going to be as excited about that. So if it's something that exists already and you're taking a little bit of a difference to it or something, then I think we would prefer that. So it doesn't have to be the most novel new thing ever. So you're saying like a playing card reader for poker. Oh, I like, that's a really cool idea. Does that exist? I've never seen that before. Does that exist today? It does? Okay. Well, I bet you could make a better version because I wonder if the existing version uses deep learning, right? So yeah, that seems like a great project. Yeah, because it's not something that like, I don't know, if your project proposal was something like, I don't know, what's like a very common computer vision? I guess if you were just doing like a license plate reader or something, like that's pretty common. We'd want you to do something a little bit different, maybe a little variant on that, like license plates and low lighting. But no, the card reader, that's a great, I like that idea a lot. So yeah, Austin says, is it mostly going to be deep learning? You do not have to use deep learning in your project, but we're going to really encourage you to, mostly because if you use deep learning, you can like get state-of-the-art results, and in some cases, like we've had groups do stuff that's never been done before. So we're really going to push you towards doing state-of-the-art things, and deep learning really is the state-of-the-art in computer vision. So you don't have to do deep learning, but you'll usually be happy you did, and we're going to try to make you do deep learning.
Yeah, just to add for what Austin has added, Austin has asked. The input data should be either images or videos.
That's right. Yep, absolutely. Thank you, Arvind. Yep, absolutely. So yeah, the input does need to be images or videos, correct. And most likely doing something with deep learning. All right, cool. And you don't have to, remember, you don't have to craft your proposal around deep learning. A lot of folks in the class have not used deep learning, and that's totally fine. Like the card detector, all you have to do is describe what the system would do, and you don't have to worry about describing how it uses deep learning. That'll come later in the course. All right, what other questions can we answer? All right, Vanessa says, the threshold for getting the direction of edge is different for many images, right? So what is the best way to get a threshold dynamically? Should we get an average value by reading every pixel and use it? That's a great question. So what you can do is you can visualize several images at once in Jupyter and try to find a threshold that kind of works for most of them. But you're right, that's going to be challenging, right? So you could, for example, you could compute the mean. Another example, Vanessa, is there's a couple other things you could try. You could compute, like you said, the average, like you said. You could compute the min and the max of the image, and then you could take the average of those two, for example. Or you could do something interesting. You could actually, like, instead of taking the threshold being like a hard-coded value, you could actually do like a median or a percentile threshold, where you would take like the 100 largest values. So there's a bunch of stuff you can try. I think just using a fixed threshold, if you kind of tune it and experiment, you may get pretty far. But I think if you do want to like be at the top of the leaderboard, you may have to do something more sophisticated. And for that, you could do it dynamically using the mean, like you said. You could do a percentile where you take the top 5% of detections and use those as your edges. There's a few options. That's a really good question. So Ravina says, I have one more question. I see that we are using different thresholds for different images. Oh, that's the same question almost. You said, how do we handle it in our code where we will be processing random images? Yeah, same exact question. So yeah, so here, to get this to work well, I ended up using, what did I use? And maybe there's one for balls and one for bricks, but you're not gonna know ahead of time if it's an image of a ball or a brick, so you can't, you won't be able to tune that. Let's see if 0.5 would have worked here. Let's see. I'm thinking, oh, not great, actually, not amazing. Let's see, what if I use 0.7? Okay, it's still not very spiky. Oh, that's the wrong image, sorry. I have to be careful with Jupyter sometimes. I need to reload this image. Yeah, that's why it was being weird. It was the wrong image. Hold on, 1 second. Yeah, okay. So if I used 0.5 here, I think we'd still be pretty spiky. Yeah, it's still pretty spiky. Yeah, so I would try it first just to find a kind of a threshold in the middle and see how well you can do. And then once you have that kind of working, you could expand and try to use a dynamic threshold. But you should be able to get pretty far with just one threshold. I was just experimenting a little bit, but here you can see I've gotten pretty good results using 0.5 for both. Cool. All right, so I think I answered this one and this one. Okay, cool. Our code is mainly functional, I think, which will be used for. Okay, our code is mainly functional, I think, which will be used by the projects in the code. Okay, I see, I see. Oh yeah, great question, Austin. So what is the input to your function? And Ravina has the same question. Yep, perfect question. So if we go back to sample student, let's see if we have any hints for you here. Yeah, so if you look at, you're gonna write this method called classify, right? And that's what we have in sample student for you. And it takes in an image. And the image is going to be a n by m by 3. So n is the number of rows, which could change. M is the number of columns, which could change, but it will always have three color channels. And that's what you're going to be passed. So we're actually going to take your method and we're going to evaluate it actually a number of times on the test set. The test set is probably, I can't remember how many images, it's probably 20 or 30 images, maybe a little bit less. But we will analyze we'll use your method to process every image in the test set, and your score is going to be based on how many of those you get right. And actually, what you can do is we have another method we included, and it's actually the exact method we use to evaluate your code. There might be one little tweak, but it's very similar. So this evaluate.py, you can run this and it will do exactly what's going to happen on the server. It's going to take your method, which let's see, where does it actually run your method? Here it is right here. So you can see we're running your method right here, classify. It will take your prediction and we compare your prediction to what the actual class is, and we use that to compute your performance basically, and we print it out, and that becomes your score. So the input you should expect then is an image. Hopefully that answers your question. And you can even run this evaluate.py to do exactly what we're going to do, which is pass a bunch of images through your method. Okay, hopefully that makes sense. Is the time taken for processing our images part of our grading? So it's not part of your grading, but we do cut it off. Arvind and Rohan, I'm not sure if we've quite gotten there yet. I think we do have a cutoff for this programming challenge. I want to say it's 5 or 10 minutes of processing time. Do you guys remember?
It's 180 seconds as far as I
Oh,
remember.
180, okay, it's 3 minutes. So yeah, your code, as long as your code takes less than 3 minutes to run, then you'll get then you're fine. But we'll cut off your code at 3 minutes actually, right? So if you have something really slow, and the Huff transform can be very slow, so you may time out basically. Yeah, good question. All right, what else can we answer? Hopefully you guys are liking the class so far. I guess we're 2 weeks in now, so you're starting to get a feeling for what the class is kind of about. Just in general, we'll have this unit done, I think in 2 more weeks. Yeah, 2 more weeks this unit will be done. And then we're going to start getting into machine learning, neural networks. We'll just spend a little bit of time on autonomous driving, and then a big chunk of time on deep learning, and then finally 3D computer vision. So Austin says, I watched a video on hysteresis thresholding. Yeah, cool, and the Canny operator. We'll be able to use these methods. Yeah, so would we be able to use other methods of edge detection than the ones gone over in class? Yeah, Austin, so absolutely. So here's the thing though that I wanna just get you thinking about a little bit. So you can use whatever edge detection method you want, doesn't matter, as long as it's written in Python and NumPy and as long as you write it, right? And I bring that up because, so the Canny edge detector, is a really great edge detector, but writing that in Python would probably take you a while. I've never written it in Python. You could do it, but it might take you like a week. So you might be able to use some ideas from the Canny edge detector to make your system better. And hysteresis thresholding is a nice thing to have. It just takes a little while to code, but feel free to give it a shot. But like all I want to say though is that if it takes you, it might take a while to implement the full Canny edge detector, and you might not need it, I guess is kind of what I'm getting at. But yeah, great question. All right, what else can I answer? Yeah, we'll keep it going for maybe another minute or two, maybe a few more minutes. And yeah, if anything else comes up in your mind while you're on here, just go ahead and go ahead and let me know. I might try one little experiment while you guys are thinking, just for fun. You guys were asking about thresholding. I'm curious how well we do with one threshold. I haven't done this in a little while. I probably did this 2 years ago when I made the challenge, actually 3 years ago almost, but it's been a little while. So just for fun, let's see here. If I do something like this, I'm just curious how well a single threshold works. Let's try this. I'm going to do a subplot thing where I'll plot a bunch of different, okay, cool. So there's a brick. All right, let's try this. So let's do thresh equals 0.5. And that's a little bit noisy, but it might be usable. We'll see. Let's do this. Thresh. Okay. So let's do fig equals figure. I'm just going to do a big subplot thing. You'll see what I'm going to do in a second here. Let's do 14 by 14. Let's do a big figure. And let's do for I in range of, let's do like a 5 by 5 grid. Let's do 25. Let's do fig.add subplot of 5 by 5 by I plus 1. Okay, cool. All right, so this should make a big subplot of a bunch of images, and we'll see how well this threshold does. Oops, I didn't run this cell. Okay, cool. All right, let's see if this works. It might take a second to run. I just want to see how well this one threshold does across 25 different images. Let's see. Oop, I found a bug in my code. I wasn't taking I. That would be running the same image again and again and again. Okay. All right. Yeah, I just processed the same image over and over again. All right, let's try this again. So at the threshold of 0.5, I want to see how well we do across a range of 25 images. Let's see. And all I'm doing here, this subplot thing, this allows you to make multiple plots in one big plot, basically. And one little annoying thing here, you have to do I plus 1 because subplot starts at 1, not at 0. Are these random images or the first 25? Great question. I thought about doing random. These are the first 25. So random might be a little better, but these are just the first 25. Oh, that's kind of fun. Okay, cool. So I don't know. I don't think this is terrible. I think we're doing reasonably well. You got some noise, right? And I guess some of those bricks are pretty noisy, right? Like that might throw off your algorithm depending on how it works. Those are probably the worst, these bricks here, right? But for these other ones, like that's not bad, right? And it's just one threshold. Maybe we try to raise it a little bit and see if we can get rid of some of this noise. You may also be able to get rid of this noise by smoothing though, right? I'm not doing any smoothing, right? So if you do like a Gaussian smooth or something, you may be able to reduce some of this noise. Sometimes you can also reduce noise just by reducing the size of the image. Although actually we don't have a good way of rescaling images actually, so that's not really going to be an option. Are these random images or the first 25? If possible, could you do some hard images as an example? Oh, sure, Austin. Yeah, great question. Now, the hard images, man, okay. So let's see here. And just so you guys know, the person who did best on this challenge, it was the very first year. They got like a 90% overall, which is like crazy. They got like half the hard images. So the best result we've ever seen ever in the history of the course got like half of the hard images right. But what's cool is we're going to use deep learning at the end of the course, and you're going to get like 99% of them right using deep learning. Okay, let's do hard. All right, here we go. Ready? This is going to be crazy. Let's do just 16, and let's do 4 by 4 so it goes a little faster. Okay. All right, here we go. Hard images. All right, this is going to be brutal. Let's see. These are here for challenge purposes. But like I said, some students do enjoy trying to do this. If you want to really compete on the programming challenge, if you're out for the $10 gift card, then you should worry about the hard images. All right, let's see. So Vanessa says, is the thresholding that we are using our simple thresholding, Professor? I read about 3 types of thresholding, which is simple, adaptive, and OTU. Okay, cool. Yeah, we're using simple. Yep, great question. Adaptive is kind of what we were talking about a little bit. And yeah, I think I've heard of this OTU, but I've never used it. So this is just simple thresholding. Yeah, great question. There's a bunch of literature out there and reading you can do on traditional computer vision. We're only going to spend like, I don't know, 25% of the class on traditional computer vision. There's a bunch of books and stuff, and they're great. It's just like now in the last 5 to 10 years, deep learning has replaced a lot of this. So we're going to do just enough traditional computer vision to really get you comfortable, to know what kind of the big ideas are, and then we'll move on. But Otsu is another way to do thresholding. Okay, so look at this mess, right? Look at this craziness, right? So hopefully that's what you wanted to see, Austin. This is pretty crazy, right? So you see some details going on there, but yeah, pretty crazy, right? So if you could imagine, let me just do it for fun, right? So let's do this direction of edges thing on one of these. I don't think there's gonna be any kind of signal. I guess I could get really fancy. Yeah, I could actually do this, right? I could do direction of edges on everything, and then I could plot the histograms. Yeah, and what I could do is I could plot the, okay, so I'll do title of the IM path of I, so we'll know what the image name is, so we can tell what it actually is. And I'm gonna show a histogram. I'm gonna look at the histogram for all 16 of those images. All right, this is gonna get crazy. And we can do the same thing for the easy ones, if my code works. Let's see. Oops, that's not right. It's supposed to be G direction of G greater than threshold, or just thresh. G greater than thresh. Yep, thank you. Cool. Let's see. All right, this is going to be gnarly. All right. Oh, no, what am I missing now? Okay. I am paths of I. There we go. And I'll do this again for the easy, just to see in a second. Okay. Easy. All right. But the hard, this is going to be messy. There's going to be like no patterns. Let's see. This might take a second to visualize all those histograms. All right, little MacBook, you can do it. Maybe I should have done a 3x3. I think it takes longer with, yeah, the harder images are going to take longer because there's going to be more points. Those histograms are going to be really slow. Yeah. All right, it's coming. This might be the end of the review session where we just watch my computer try to make a bunch of plots. All right, I think those histogram ones take a while, I think is what's going on. Yeah, that should be the only problem. Yes. Okay, we'll give that one more minute. Yeah, this should be cool to see. Let's see here. I'm predicting, so we're going to look at a bunch of these plots, right? We're going to look at one for each image. I'm predicting for the hard images, you just see like, they're just kind of like random. But I bet when we do, oh, there we go, cool. Okay, let me make this a little smaller. All right, fun, okay. So here are, oh, you do see some kind of spikes in the hard ones, but like, what do those mean? Let me go ahead and run the easy real quick. But yeah, here are the histogram plots you get out for each of the images. So here's a brick, here's a brick, here's a brick. The real question is, do the balls look different? So these are the hard images, right? So there's so much noise, it's going to be hard. I am curious what those big spikes are, because we do see some kind of consistent spikes in the hard data. But here's a brick, here's a ball. Hard to see a pattern, right? Cool. Maybe the textbook. Yeah, it's a good idea, Austin. Yeah, it could be the textbook. Now this is nice. Look at this, right? So we've got these bricks. So all these bricks, for the most part, this one's a little noisy, but for the most part, the bricks have that nice spiky behavior that you expect. And look at your balls, right? So each of these ball plots, right, has a nice, like smooth, and they're all like less than 40, right? So using subplots is a nice way to look at more of your data as you're choosing thresholds and stuff like that. And yeah, we will definitely share this notebook, Ravina, no problem. I think I made 2 notebooks, I think, or maybe it's just 1. But yeah, absolutely. I think I'll just export it as an HTML. I think this has pretty much everything. This is ideas on the programming challenge. Then I guess I closed that other one. The other one just had some magic function stuff, so that probably isn't a big deal. But this one, yeah, we will get this shared on Canvas, no problem. Okay, well, that was kind of interesting. I'm glad we looked at some subplots. I forgot where that idea came from, but I think that was pretty cool. Great. All right. Any other questions? We got just a few minutes left. We could definitely end early if there's no more questions, but if there are, I want to make sure I get them answered. Anything else while we were on the call? Yeah, and we'll send the IPython notebook file. My downloads aren't quite, why is that a JSON? I think there's something weird about my configuration on my MacBook. That really should be a .IPython file. Weird. Okay. Because this is actually, yeah. Okay. This is what we'll share with you. You should be able to see this. We'll do Cool. All right, we'll get that shared. All right, so Robert says, if no one has any more questions, could I share my screen so that we can try to get Jupyter installed for me? So I'm not a Windows expert, Robert, unfortunately, but I think hopefully after this, then one of the TAs can help you on Piazza. So cool. And then, yeah, and maybe Austin can help you as well. Perfect. Okay, great.
I replied to him on Piazza, Professor.
Okay, cool. Yeah, so you should have a response, Robert. Thank you, Arvin. That's awesome. Great. Cool. All right, great. All right. So any other questions, guys? If there's no other questions, we'll go ahead and wrap up here. Any other questions before we finish up? Okay, cool. So Robert has a question. I'll let you guys discuss on Piazza. Okay, all right. So Robert, I hope we get your Windows issues figured out. I'm sure we will. And if you guys have any other questions, please put them on Piazza. I hope this was helpful. We'll get this notebook out, and then I think we are recording as well, so we'll get the recording up and running. Great. Cool. All right. Well, thank you guys for your time today. I hope you enjoyed this. We'll talk to you on Tuesday. Do start on your programming challenge. It is due not too long from now. And if it feels like your solution is kind of weird and hacky, then good. That means you're doing it right. So there's no one answer to the programming challenge. Really, it's a chance to be creative. So I'm excited to see some creative solutions. Great. All right. Thanks, guys. Have a good one. We will talk to you on Tuesday.